Hello and welcome to the third lecture of Module 1 Introduction to Design Thinking of the online course Design Thinking for Engineers. So, in this, we'll be looking at the various principles of design thinking, the challenges in design thinking, the design thinking methodologies, the stages, and the final aha moment of when you come up with the solution. Maybe I'll try to have this little. I'll take a few of these into the next lecture maybe, because you don't want to I don't want to dump a lot of information to you in a single lecture. So starting with the principles of design thinking, as I told you earlier, it's a human rule and it isn't based on any ambiguity. So the rule of ambiguity here means that you don't need to assume anything and come up with solutions to a assumption. You need to come up with solutions to a real world issue, and it's a tangibility rule. I'll explain all these four rules here. So the human rule means that the design is social in nature. What do you mean by social in nature? You're going to interact with the customers, the people who face the problem, and you're going to come up with solutions to it. Is the solutions going to be a single off solution? No. You'll be going back to the people, again come up with a corrected version of the solution. It's an iterative process, as I told you earlier in the previous lectures. So in the ambiguity is inevitable here because you don't imagine anything. You need to experiment it at the limits of your knowledge. You don't imagine more than that. And all design is redesign. Which means that you need to come back, keep changing the techniques, keep changing your methodologies, even if it has to, for example, if you are doing a project and if it doesn't work out properly. In design thinking, you don't care about the cost of the product. You go back, you take an entire new materials, you start working with it. You change your entire design process. So in design thinking, everything is kind of rapid. You need to, as I told you, you need to fail a lot in design thinking. And the tangibility rule. Prototypes here help to make ideas tangible, enabling designers to communicate them effectively. You don't just come up with a software module. You don't come up with a PPT, for example. You need to come up with the prototype as such. You don't promise people of things. You need to show them things. And the challenges here is that the problems are wicked, which means that they aren't properly defined. And the problem statement and the solution are both unknown at the beginning of the design thinking exercise. In a well-defined problem, at least the problem statement is clear and the solution is available through technical knowledge. Whereas in wicked problems, the designer may have a general idea of the problem, but significant amount of time and effort goes into requirement analysis. You need to think of what will be the requirements and the materials that must be put into the project. The requirement gathering, problem definition, and problem shaping are major parts of this aspect of design thinking, which is defining the problem. So these are the various parts you need to keep in mind while in the process of design thinking, basically. So talking about wicked problems, every problem is unique and there is no clear problem definition. All multi-causal, multi-scalar and interconnected. And there are multiple stakeholders with conflicting agendas. Every wicked problem is connected to others. Solutions are not right or wrong, but better or worse. I guess you can understand it here. Solutions are not right or wrong. The solution must be better or it must be worse than the previous solution. So it can take a long time to evaluate solution. And problems are never completely solved here. So going on to the design methods, the 5 whys. Why is it happening? Why is that? Why is that? Why is that? Why is that? You need to keep asking the whys. Excuse me. It's an iterative interrogative technique. You need to you need to keep asking the question why. For example, I'll be explaining it soon. This technique helps to determine the root cause of any problem. So I'll explain it in this slide. The why approach here is, if there's oil on the floor, you need to ask why. Because oil leaks from the cylinder rod when activated. Again, why? Why did the oil leak? Because the O-ring was cut. Why was it cut? Because the rod was flawed. Why was it flawed? Because there is dirt in the oil abrades the rod. The dirt in the oil abrades the rod. Why? Why did the dirt get into the oil? Because there are holes and gaps on the upper plate of the tank. So this is this root cause, and asking the question why five times. In the 5 iterative process, you have come up with the root cause of the problem. So this is the why approach. So in design methodology, the first approach we are learning here is the why approach. Then the 4 W's approach. The 4 W's are who, when, where, and why. Who is experiencing the problem? The end user. Who are you focusing on while trying to solve the problem? And what is the problem in the first place? The main point that stands in the user way. And where is the problem happening? Is it physical, mental, or digital? What's the context around this problem? And why is it important? Will the user get substantial value out of the problem being solved? You need to first evaluate the problem. You need to give it a rank. If there are going to be 5 problems, you need to have a priority of which problems must be solved first. And then among the various solutions for that particular problems, the various solutions must be ranked. And these solutions must be tried. All the solutions must be tried in a priority basis. It's not about analyzing the solutions, it's about trying the solutions in the real world and coming up with the best solutions. You can't just think of a solution. You can't rate your solution in your mind. You need to work it and get the output. So the point of view approach, the third approach here is the point of view approach. You need to we use this Mad Libs, right? We'll keep prompting the speaker about why, where, and stuff, so that he can come up with the answer to it. So the user needs to, what does the user need? What is the insight because of which the user needs to have the requirement? This is called as a point of view approach. You need to keep adding this trigger questions in this approach, so that you can come up with a final beautiful solution to the problem he faces. For example, an adult person who lives in a city, to use a car for 10 to 60 minutes, 1 to 4 times per week. So this is the need for that person. This is the need. And the insight is, the user would not want to own his car as it would be too expensive compared to his needs. He would like to share a car with other people who have similar needs. However, there are no easy and affordable solutions for him. It is important for the user to think and live green and to not own more than he truly needs, because a car at the end of the day becomes a luxury for him. He has it's too expensive when compared to his other needs. So this is the basic point of view approach. So instead of saying we need to design X or Y, design thinking explores new ideas and solutions to a specific design challenge. Note this first phrase, instead of saying, we start doing. It's time to start using the design thinking method, where you ask, how might we? These are 3 very important words. How might we? In the how might we approach, this is going to be the 4th approach. How can we do more? So that's going to be the first HMW approach. The first part is, how can we do more? And how can we do it differently? And how can we scale the solution? That is, how can we go further? So these things are various approaches towards design thinking. And again, as I told you in the lecture 1, I guess, each each approach is specific to each problem type. For example, the HMW approach might not be feasible in the case of a few solutions, which may be solved by the 5Y approach or the 4W approach. The fifth approach is reverse brainstorming. Instead of starting with the problem and ending in the solution, you can start the reverse brainstorming session where you can come up, you start with the solution and you go up to the problem. So it flips the traditional brainstorming technique upside down. Instead of trying to solving a problem, reverse brainstorming generates ideas to make the problem worse. Then you reverse those ideas and solve the original problem. So the thing is, this technique builds on our natural ability to more easily see the problems than solution. For example, in the case of a musician, while listening to a music, you might know that the lyrics is wrong, but you don't know what the true lyrics is. The lyrics are right. So this is a type of thing, because we can easily point out the problems in any situations and solutions, but it's difficult to come up with the corrective measure for that problem. So first you identify the problems and then come up with solutions to them. So in the example of a reverse brainstorming session, we need to increase sales. How do we first think of how do we decrease the sales? So what are the what are the various things that happen in our current situation or our current business model that are decreasing the sales? So first think of how do we decrease the sales, so you can easily come up with problems for decreasing the sales, right? And for each and every problem for decreasing the sales, you can come up with a corrective measure. So this question is being answered without asking this question, but by asking the opposite, the negative of this question. I guess you can understand this concept. So this is the reverse brainstorming approach, the fifth approach in the design thinking process. This Iron Man suit, which started with the Mark 1 and then went up to, I don't know, Mark 50 or something, the nanotechnology approach. So how Tony Stark designed his suit in a step-by-step manner. I guess you guys would have seen this series of images. Ant-Man went into his suit and damaged it in, I guess, the Civil War. And because of which he started using nanotechnology. And the flight is a little unstable, so he fitted flight stabilizers in his suit. And in the first part he was kidnapped and nobody could find him, due to which he had to add a GPS tracker in his suit. And he had a problem with shooting, so he came up with auto aim missiles. And this is again from the Civil War, I guess. He had no safety on big height, so he fitted a parachute to the suit of Spider-Man. And he wanted big cannons, because the cannons in the Hulkbuster suit wasn't that efficient, so he came up with his own cannons. And his suit wasn't meant for combat, due to which he brought in more elements like a shield, a hand blade, and a battering ram. So, and there was this coldness issue. I guess this was in the third part of Iron Man. And he fitted in a heater in the suit of Peter Parker. So if you could see, Tony Stark himself used the design thinking principles, is repetitive corrections. So he made several corrections in his design, right? So this process is basically design thinking. So there are 5 approaches, as I told you earlier, and think about it, and feel free to ask your questions down in the comment box, and see you until the next lecture. Thank you.